what it was like to create that tool and why we created that tool. I've got some slides prepared more as a notes to myself, so don't pay too much attention to that. I'll first talk about some stuff about why we created the tool, how it was made, and why I think more people should be creating tools. And after that, I would like to just really showcase the tool that we have and show some of the demo effects that we did. And if anyone wants to ask questions, feel free to raise your hand, and maybe but yeah, let's see where we go. So I think there's two types of people in the demo scene that that I meet. One of that is the creative type. That is not per se a coder, but that's someone that can do awesome creative visuals on a screen. With potentially real time, but mostly just in 3D modeling packages or Photoshop, or just create really cool stuff. And then there's the coder in the demo scene that probably is a bit of both. I mean, most coders here are creative and can output cool visuals on the screen, but they sometimes need help from these creative people to just really get their demo to the next level. And I just want to make a case for coders to make more tools and include creative people more, and for creatives to try and use those tools and give feedback on them, so that together we can get more demo groups that include sort of both of these types of people, and together create better productions, which is what I think we try to do, although most of the people that work on our demos are also slowly becoming more and more coders. So, so maybe our tool forces people to learn how to code, but I hope it makes it easier for those people to get started. So I'm going to be fairly biased in how I approach this, because I'm going to be anecdotal about this. I'm going to just share my experience, and I will probably make ray marching sound easier than it is, but it is really not that hard if you just get started in an existing framework. I believe the guys from Mercury released a library a couple of years back with a lot of documentation on their website, and that's what got me started. And just taking a shader toy shader template, I could just fill out that one bit of code that is the 3D model of the ray marcher, and that's how I started learning how to code effects in fragment shader. And so that's what this whole tool is doing as well. And I've also always worked in a team, so I'm just going to try and advocate for people to work together, and I think it's very powerful if you have people to bounce ideas off of, people that give feedback to you, people that fill in the gaps where your weak points are. Even though it's not always easy, because you have to make concessions with each other about the product that you're creating. But that is just my experience. So for the creatives, I'm going to say just do it. So I've talked to a lot of people that have a hard time getting their first production out, have a hard time knowing where to start and how to get into this real-time demo compo. Because there's a lot of people that do modern graphics and draw amazing stuff, that 3D model amazing stuff, but then don't really know where to go from there to release that. And I'm just going to say, find tools out there, talk to coders. Most coders will have something that maybe you can work together on, because they have the knowledge to make a real-time entry, and you have the knowledge to make it really pretty. So try and find overlap, and just try to learn what a coder can offer you, so you can work with him, but also try to stick with what you know, because if you start where you have affinity, that's where you will grow very fast. So I'm a tools guy professionally, so I have a lot of affinity with Python and the Qt graphics library, or the UI library. And so I started there, just make a tool that does what I needed to do. And that's just all about starting with what I know and trying to grow that into that goal of releasing a real-time demo. So for coders, I'm going to say, make it easier to use whatever you have. Like, as a coder, I mean, I became a tools coder because I got annoyed with tedious jobs, and I tried to learn how to automate that stuff. And I think we can automate anything that's tedious, and I think we can automate a lot of complexity away and hide it from the user. And that's going to include a lot more creative people when you want to work with them. If a creative person doesn't know anything about code, If you can help them get their content into your 3D renderer, then then the easier you make that, the more likely creative people will want to work with you and will share their 3D models, their ideas, and their work with you. And together you can really make your pipeline really accessible and usable so that it becomes accessible for anyone that wants to just try it out. Admittedly, I'm not there yet, but this pizza in the background was created by someone that has little to no coding experience and just sat down for an afternoon and used my tool to learn a bit about GLSL and just code this thing together. So I'm gonna talk about why you're probably already doing tools and how we started making a tool. Because I started with 4Ks. And I just had all my code in one CPP file, and then you would just have a C string with your fragment shader, just hard-coded in there. And very soon you'll just have a simple running application that shows what you need in one page of C++ code. But then when you want to start to change that, that's when you want to have some tooling, some pipeline, because you don't want to change a C string somewhere inlined in your code that is your entire demo. So I went to File.io and I just made my demo, a copy of my demo, and just made it not exit automatically after the music stops, maybe not play time at all, and just have a file watcher on it, so I could just type a shader, save it, and see my result in a visual screen. And that's a lot like how ShaderToy works. And I think that already is a bit of tooling that everyone is probably doing, because you don't want to wait and compile and launch your program and see if your color change actually works. And just this single bit of tooling allowed me to already be sort of pedantic about color usage. We really, if you can save and see your result in a window instantly, you can really tweak little details about your demo, and that will make it so much better because you can really get the image from your head into the screen. And just by reducing iteration times, by making it less tedious to polish, it will allow you and other people to together work on this stuff. So for SqrMelon, we really sat down wanting to make a 64K as Poo-Brain. We first used another tool called Touch Designer, which we tried out for a bit because it was very easy node-based workflow where you could click together text snippets into glrect calls. So you have screen space ray marchers. But that was not customizable enough for our needs. So we wanted animation and flying around with cameras. So we sort of learned what we wanted to make and just said, we're only going to do ray marching because it's simple. You have only the fragment shader to worry about. We're going to have all the scenes share the same logic. So every scene just uses the same ray marcher code, same materials, same lighting functions. So we can all sort of hide this away in include files. And when a creative person wants to create a new scene, they just need to fill in that distance field that creates a model and maybe type out, like, I want this directional light, I want this point light. And that's all you need for someone that doesn't know how to code a lot. They need to learn a lot less all of a sudden. They can just fill out 2 or 3 functions, and then they can create content in your framework. And that's what we started out with. And then people could individually already work on their own scenes while I continued working on the actual tool with animation, support, and that kind of things. And version control was very important. I actually learned that not everyone knows how to use version control, so it's fairly important to figure out a good way to work together as a team, to merge conflicts, to work on each other's scenes, create a Slack channel where you can just say, hey, I'm going to touch these files for a while, so please don't work on them, and make it easier to just work together and get less overlap and teach each other how to deliver stuff to each other, because not everyone wants your code golf stuff. Sometimes you want to share your code and have it well commented so that another person can actually find and change details of your scene. So then the next stop for our tool was to create some sort of management system where everyone had their own sort of effect, their own scene for a demo, and we could sequence them on a timeline, and we could sort of figure out whose part of the content was going to happen when. And then we really had a time slider where you could just walk through the demo. And also one thing that we decided what to do was to use as little explicit stuff as possible. So all of our animation is curves, and there's rarely any sort of physics simulation going on or anything that requires you to sequentially update the viewport. So we just try to animate everything by hand so that you can jump through the time and predict how that frame should look. And then, we had sort of a basic tool. People could make content, commit it to version control. We could pull it in and see everyone's scene on a timeline. And then, in my case, we created an exporter for that would generate C++ code and then just save it out as an executable or compile it to an executable. I think I have some overlap with what I just said and what's in these slides. I guess we had this basis and we kept moving with it and just looking at what we needed. So I think I'm just going to show you the tool as we have it actually right now. And this is opened up with our first demo called Eidolon, which we made in it's just parallel to the tool. So this was revision 2 years ago, where we actually won the 64K compo, which I did not expect, but I'm super happy about. And basically, this is the project that we have. I sort of got it to work again because, of course, feature changes broke the old content. But the cool thing is that as a user, you can dive into this tool. You can just start looking through the scenes, looking through the time, and see what's happening. And I think this is where I'll just show a bit about how this tool works, because there's a lot of different parts. From a technical point of view, I first made a whole framework. So this thing is a ray-marched renderer with just a lot of materials and lighting and a lot of features in there for soft shadows and height maps and texture support. And all that is actually hidden away from the user. So as a user, you create scenes in this window here. And in a scene, there's only a few functions exposed. So as a user, you can just open up the distance field of this scene, and you don't even need to know how a ray marcher works. You just need to know how to write a distance function. So this is ages ago, so I'm just gonna browse around here. But basically, the file is just this one function that you as a user can fill in, and we try to document the features that were there. We try to use the library that Mercury released to make it easier for people to learn how to write the content that we need. And basically, just spending 1 hour a day, a creative person could actually learn how to code a distance function, how to code a material, how to change the colors, how to change the lighting. And then all the animation is just user input. So if we look at a camera shot here, I can actually zoom in on that so that it loops. And then there's the animation for that is all here visually, so there's no hard-coded animations going on. I mean, you could, but it's just less convenient. And this really allowed us to make a scene, work on it with some coders that just do these 3D models and that do some colors. But then we could also sit down with people that have a better eye for animation and motion to just do good camera framing, do good lighting, just sit down and together change the colors and the lights and tweak this until it just looks pretty. I think this really empowered us to work as a team where not everyone needed to be extremely technical and understand how ray marching worked.
Can I ask you a technical question?
Yes, please.
So this throws out a 64K, and do we have any measure when you're over it, when it's too big, or
No, but we've actually had very little problems with that. So I don't even minify any of the shader code because we've never been that close to the 64K mark.
So in the theory, it could be much, much bigger, but...
I think you could make something fairly long and it would just compress really good. So of course there's limits, but 10 minutes is enough, right? This thing was 7 minutes and it was well under 64K. Of course we had 64Clang 2 for this as a synthesizer, and that also compresses really well. So it's a very small synthesizer. Maybe that saved us a lot as well, because most of our demos use 64Clang 2. But even then, I've not really hit the limit because the system is so simple. There's a very simple C++ application that can interpolate animation curves like you see here, and then forward them to a fragment shader like you see here. And that fragment shader is all text. Text compresses really well. And the code just always stays the same for almost every demo. We use pretty much the same code. It's just the fragment shaders that change, but the C++ code is identical. And as far as I know, as long as you have bigger shaders, they keep compressing really well. C++ itself, if you write more code, it will compress less well. So it's actually a good choice to do ray marching in a size-coded entry, because it's likely to stay small. So this is our scene manager, and people create and write shaders in it. And we can just change some lights if we want. I can disable some crazy stuff. I'm in the wrong scene. This is outside, of course. So now there's only one directional light, and it's actually coming from the bottom. So let's flip that. So here you can see already, it's quite easy to double click on a function that you want to change, like the lighting, and then you just start typing away. And of course, this might not be as intuitive for everyone, but I think if you just sit down and explain how this stuff works, or document it very well, it will not be hard for someone to pick up that you can just change these numbers for the light direction, and just change these numbers for the color. And that actually gives someone a lot of control already. You can just really tweak the lighting of this scene, and anyone can do it now after I just explained how to change the directional light. So that was very important for us to really try and hide all the complexity that is to do with making a demo, to try and include more people. And yeah, again, I'm really not there yet because people are writing a lot of code, and it would be way cooler if you could just have a color picker and a slider and just a 3D widget that you manipulate in this viewport for your lights, but that's just a step too far to do in my spare time. Yeah, this is scenes, and then we also have the timeline where you have all these colored blocks, and they all represent different camera cuts. So hard jumps between animation, or hard jumps between scenes. And those shots are also in this long list. So there's actually a lot of content in this demo. It's one of the longest we did, I think. And every shot is containing all these animation curves again. So anyone can just go in and say, you know, this outdoor shot where the ball rolls out of the thing, I'm not really sure about the camera framing. So you can click it, duplicate it, disable the current one, and at the bottom I've created a copy, which is the same camera shot, but I can just go in here and say, I'm gonna redo this camera animation. And I can just fly up here, closer to the thing. See, where does this ball go? Just pull out from it in the front. And then suddenly I'm animating, and this is also fairly easy to teach someone that wants to take control over this system, and it really allows people to just, I make this scene, I make the colors, someone else makes the lighting and decides on the look and the mood, and again someone else can animate the ball and the camera and all the details of it, animate the blinking lights on top of this, or have the sun go up and down. And this animation graph is really based on Autodesk Maya, which I've worked with a lot. I learned it in school and now work a lot with it professionally. So it's not exactly the same, but if you have a 3D modeler that already knows this program, they can probably already use this animation graph. And I think that's also important when creating a tool. I like to try and stay with what people know. So I work with people that maybe know Autodesk Maya, so I try to create a curve editor that looks like Autodesk Maya's. And it's also when you create a tool on Windows, you just make selection here similar to how you select files in the Explorer from Windows. And just try and keep things as close to what people know, so it's way more intuitive to pick up. Because intuitive is not necessarily about very clever and good UI design, it's also about figuring out what does your user use on a daily basis, and how can you get the interaction that they understand, that they're used to, into your tool, because then they will just try the same stuff. There's a lot of things that basic operating system usage introduces you to. So you could try and invite people to use the same mechanics, like clicking on stuff to see the details of it, or right-clicking stuff to reveal a context menu. These are all, not everyone is used to working in that way, but depending on your users, you might find that certain hotkey combinations and certain behaviors will be very intuitive to them, and then suddenly someone can just pick up this tool and ask way less questions than you would if your tool was just really, I guess I call it a programmer interface. Sometimes there's these interfaces with a ton of buttons, and you can't really make out where to start and what to do. And that's because when you develop a program, you just add a button for every feature you add until you have this big page of buttons and stuff that it does. But if you think about your program beforehand, what should it do and how should people interact with it, then you can really design the interaction and the usage tailored more towards the user, and it will require a lot less explanation, I hope. So yeah, maybe I'll just scroll through this demo a bit more. I haven't looked at this in a long time. Oh yeah, I have volumetric textures, which I've used once, but they still work, so that's pretty cool. That's all the changes I made in the past year.
Can I ask you a question? How long, because I remember seeing this demo and it was super awesome, and does the development of the tool and the development of the demo go hand in hand, or was it just like step A, step B thing?
No, it was very, very much hand in hand. I mean, we started not with the idea to make a tool, but we started with this Touch Designer program, and I wanted to make a window in there where you could use WASD for camera flying, and just taking keyboard control from that program, even though they had a Python scripting interface, it wasn't really possible, so I couldn't really nicely make my camera fly through work as I wanted it to. And there were more issues like that where I couldn't nail the way I wanted to work inside of that software. So I just sat down for a weekend and just made what we had again in Python and Qt. And that's just what I know, so that's why I picked it up. Yeah.
Have you looked at other demo tools for inspiration? Or this for staying clear of other ideas?
I'm not sure how many other demo tools I knew at the time. I mean, I know a lot more right now. I think I've looked at some demo tools from Blueberry and from Logicoma and saw how they worked. And they were node-based programming interfaces. But we were already in Touch Designer trying to create just a framework where people would fill in just a few functions so that it would be accessible and not very programmer oriented. So I think my tool is very different from those tools. Even though I did look at them and thought they were awesome, they were just not suited to what I wanted to do, which was just a ray marching tool. Nimtek? It's all functions. It could be probably made visually with visual programming, but I personally think that's not worth the effort actually to make a visual programming tool to do this kind of stuff, because the modeling is not that hard to learn, and it's also very performance heavy, so you have to get pretty clever and do some tricks in your modeling code to make it optimized. And with a visual programming tool, you're much more likely to create slow performing models. But we can totally dive into some of this stuff. If I can remember where I put the distance fields. Nope. I wanted to show the main character because it's just a sphere and fairly simple model to show, but that's not gonna fly, I'm afraid. Let's see if we have something else. Maybe this could work. Right, so this is all living somewhere else. Why can't you find it in the directory? Oh, there we go. So there's an actual file called models, and I'm just blind. Cool. Don't mind that micro business. So let's look at this guy. But this is all very long ago for me as well. Okay, so the tool actually automatically picks up on any animation you do. So for example, in this animation of this scene, there's like a main character position and some other stuff, of course, as well. But this, you can just type, you can add a channel called, for example, I make just a fade of something, and then I can actually in the shader create a uniform with that name, and then that will be picked up. I'll get back to that later, by the way. Let's just first focus on this model. Also, the main character is jumping around because this demo was using some physics, so there's some weird prediction logic here that is not based by the anim curves, but so the position is driving the ball, but then there's some spring system moving the ball around, and when I click around in the time, it all just gets messy. But let's try and focus on it, and I hope it just stays in the screen. So this main character has that uniform position, and it's gonna get moved there, and then we scale it down by a lot, because we started out with this big sphere, and then we wanted a nice and cute small sphere, so just scale it in place instead of changing a lot of code. And there's some rotation going on. So this is actually the physics system computing the roll of the ball, and then we actually apply it in the shader so that this sphere actually rotates correctly. And after that, we write a sphere, and we cut off another sphere. I'm not sure how this works anymore. I think to make it hollow or something, which I now know better how to do this. Then we cut out a box. So I should show it like this. So these are things that I think you can find online, or that can be better documented to get people started with this tool. But this is how you mirror something in the code. So with this line, I actually say I want to mirror across the center plane of my ball. And then with this line, I'm going to subtract a box from the sphere. And that's what creates these two gaps that you have. What did I do? Did I break something? I think I broke something. Ha! This is great. Also, tools crash sometimes. And of course they do right now. That didn't happen. It works flawlessly. You should buy it. Is it trying to start or is it not? Huh. So some recent driver updates made all my demos run a lot faster, but the compile times are way slower. So it's not great. We're back where we are. So we have a mirror and then we subtract a box, and that's how you get these two slits. And then we have a smaller ball inside, which is very brightly colored, so it picks up on the bloom here. And that smaller ball just gives it this nice little outline. Some scenes, I think the ball actually has a light, so you can see two little light streaks, but that was very expensive on performance, so most of the time we disable it. So sometimes we show it off, and then we hope you fail to see that we don't do it in every scene. There's a lot of smoke and mirrors going on with this stuff. I think that's important. Also, if you look at this, it's just this weird pentagon shape with a door, and then there's some weird blob with windows lighting up. But if you just look at the shots from the angle that we film it in, it kind of works. Even though there's like nothing there, you don't need anything over there because you're not going to look at it. Also, there's these lines in the side, which I think is this engrave. And this is all code that I think Cooper did a great talk on, because it's the Mercury distance function library that they released, and that has all these functions like pmod polar and fop engrave in there. And these are functions that allow you to repeat space and create models or cut stuff out of each other or create little engraves. And there's a very good demonstration of how it works by Cooper if you want to look that up. And also they have it online with a lot of documentation with screenshots. So I actually look at that still to just figure out, like, how did this work again? How do I do that? It's a very great resource that I just lean heavily upon. But that's about how you model stuff. We're missing a party. Yes, yes. So are you interested in like team dynamic, or are you more interested in how do we actually deal with file structure?
Mostly like the technical thing first.
Yeah, okay. So let's go, let's show it here. So I use PyCharm as my editor, also has a GLSL plugin, but you can really use any text editor you want. So this demo actually starts with a render pipeline. So I have this XML file that decides we want some noise texture for the clouds, we want some fonts for the credits, we want some Perlin noise, and that goes on and on and on. And then we have this big render pass, which is our main 3D renderer. And these are all separate files that are included in that. And some of these files are then called section, and they are unique per scene. So this XML file gets parsed, and when you create a scene, it will find the sections, and it will create new files for that scene of only those sections. And the other files already exist. And basically, I write a whole ray marcher with a lighting system inside, and then I just try to expose the little bits that people need to use to create their content. And then in the tool, when you, for example, create a new scene, what it does in Explorer is actually create a new folder with those files in there. So when you're doing version control, it's super granular as well. So when I change the lights on the scene and you change a bit detail of the model or the textures, yeah, it will just be way easier to merge and we'll have very little conflicts. And
You don't have to do a final merge, right? Then it's like I own this file and I do push updates.
yeah, I used Mercurial for this demo, and sometimes you do get a conflict when I change the main character model and someone else changes the main enemy model, then we have to merge, but usually we do communicate about what do we want to do. So there's some team dynamic involved as well, where someone has to have some sense of being in charge as a director, you say, to get a consistent look. And you have to have a Slack channel where you just say, hey, I want to change this and this thing, and I'm going to work on that now, and then people will know not to touch those files. And sometimes that goes wrong, but then you just say, okay, whose change is important, or how can we merge this? So it's a bit of both. How often we sync up together, or how often we have conflicts?
No, how often you sync?
Oh, all the time. So there's just a server, and we just work on stuff. And when we're like, oh, I changed this bad guy to have an orange stripe on it, I immediately submit that to the server. And everyone that will start working in the morning or in the evening when they're done with work or whatever, first thing they do is pull and just continue working. So I think it's actually very motivating as well if people keep pushing their content to the server, because I can get up one day and just see someone stayed up until 3 o'clock last night and did some awesome stuff. And then, yeah, and then I want to do stuff as well.
What also helps, I think, is that you got a message in Slack whenever it was updated, so you always knew that something changed.
Yeah, true. Yeah, we have like a Slack bot that watches the server, so you get like a little pop-up that says, "Hey, this guy pushed this change." I think it could be cool to see some other stuff. This was revision last year. Just gonna load that up because, of course, I got. I guess the framework matured and my coding skills got a bit better. It might be more interesting to see something more recent. So this is all height map texture. And what we do in the tool is we have this render pipeline where we say we have these bits of shader code concatenated together. And there's these static objects as well. And they're just a frame buffer that are rendered once. And I can just render a super expensive, crazy noise texture or something like this crazy height map, and just just use that as a texture through the rest of the demo. So it's a lot faster than doing noise for every pixel, every frame. And then the rest of the render pipeline of this demo also matured a little bit. So let's look at that. So for this one, I actually have like a separate reflection pass, so which runs at a lower resolution. So when something is reflective, which I don't think we have a lot, but I have a disco ball. What more could you want? This is the longest compile time I'm going to give you today. All right. So this reflection pass can be controlled on like, what resolution should this buffer run on. And then in this shader pipeline, I just say, all right, so first we ray trace, and then we take the output from that G buffer, we ray trace a reflection, then we reinterpolate that to full resolution, we blur it if we want rough reflections, and then in the end it all gets combined into one picture. And then we have post-processing like depth of field and bloom and some color correction and all that stuff. Yeah, so I do not use the actual synthesizer, but I just expect the musician to render out a WAV file or an MP3. And I think I might have the sound of this in there. So I just read the WAV file, and this time slider here is synced up to that. So when I just jump around in the time slider, the music will just skip to that.
This render path or render pipeline definition, there's no editor for this except the text editor?
Currently, yes. It's definitely something I want to change.
The keyframes, they're also stored in some kind of text file?
Yeah, they're also...
Basically, the whole demo is defined by a big directory structure of text files. And
yeah.
you choose for what you want to invest the time to write a nice editor, and everything else is, well, text editor.
Pretty much, yeah.
So you can basically would have been able to run the demo without any editor coding, although that would be pretty hardcore.
Yeah.
And you have a soft transition from no editor at all to maybe everything's got an editor.
I guess yes, but that's not how it grew though. I think I definitely had some ideas of what I wanted an editor for, and then the file actually exists because I was creating the editor and I needed to save what I was doing. But yeah, you're definitely right that everything like these are the animation files. So this is like a camera, and inside of it are like different curves, and this is not humanly readable per se, but it's just. But it's it's definitely possible. Also, it's great when having conflicts with animation. When I change the camera in one file and you change the camera in another part of the demo, it's the same scene. We get a merge conflict, and you have just you change this shot, I change this shot, or I touch these curves, you touch those curves. It's very clear to merge data like this as well.
I have a question about this. A problem with text formats, especially for floating point data, is that if you want to do stuff like quantizing bits of them, the floated like textual representations are usually hard to work with unless you have a binary encoding or something like that. Is this something you've considered doing in the future? I mean, you said you weren't so limited to space so far.
So not sure if I understand the question correctly, but when saving, I definitely had some issues that some platforms save more or less decimals when you just use printf. But with the actual demo player, I take all this code and generate an include file. And so in Python's memory, they're all binary, and I truncate them when serializing them to a CVP include. And yes, it's customizable per channel if you hardcode that, but my main exporter, just for every float, it just says, let's truncate it to 16-bit or 18-bit precision, and that works fairly well. I've actually noticed that mostly the camera angles and positions are sensitive to truncation, but everyone else, every other animation, you can just brutally cut off and it will look fine. So that's also that's a very ugly part of the tool. So this is all nice. You can create stuff. There's actually tools to render this to a video, and then there's one massive script that will just let's see, take all these XML files and all the shader files, and there's just a very ugly system that generates C++ text. And it's horrible to debug, but it usually works. And yeah, there's some crazy stuff you can do with macros where it will maybe fail. But it's all generating the code that you need, and then inside of the player, it will write the file if I still have it. No, I do not. It's also not in version control, this file. So. And then this is actually all those XML files, all those shader files combined into one bit of code that just interpolates the curve data with a massive float array that will just have offsets in. And yeah, it's ugly, but it compresses small. So I tried cleaner versions where I would have object-oriented code and just have some structs and then have a serialized, deserialized process so my code would be humanly debuggable. but it became like 50% bigger, 20% bigger, stuff like that. So I stuck with something very automated and very brute force, because generally I like content-driven stuff, and this is not content-driven. It's all hard-coded. It's horrible. So I don't know. Are you guys interested in seeing any more of the shader code, or do you want to talk more about the tool? Do you mean like crossfade transitions? Oh, morphing is definitely possible, especially since it's all Raymarcher based, and distance functions have this nice nature that they're easy to morph. But actually crossfading is a bit harder if you're thinking about video editing and really fading in one scene and fading out the other. It does mean that you have to render both those frames and blend them, and that will just mean you have the performance cost of both those scenes.
The render file system seems like it should be able to support it.
I'm sorry, could you?
The parts file system it looks like it would be possible to support it.
Oh, you could make it work. So, what else have we got? Oh yeah, I actually made a video clip with this as well, which might be cool. So this is how you don't care about performance. But it's, I was glad to see that you can actually do pretty good looking visuals, and especially if you don't care too much about the performance, you can really push the quality a lot. And yeah, just render to YouTube, it's fine. Yeah, that was also pretty cool. How about I make a new scene? And a new camera shot. So this is actually, I'm just going to show you a little demo of what it's like to make something. Especially since you asked about morphing objects, I can show you a sphere morph into a cube maybe. So let's say I want to control the morph with user input animation. So I'm going to create a uniform which is exposed to the outside world. And then this can be controlled by the animation curves. Then I'm going to create a cube. And let's mix those two objects. It should not really change anything until I start playing with that morph value. There you go. And of course you can sync this to the music. So that's something worth mentioning actually. Everything here works in beats and not in seconds. So I set the BPM of my soundtrack, and then the entire animation just gets scaled to that BPM. So you can just start animating at any BPM to a drum loop, and just say, I want, on the kick, I want this to animate, and on the snare, I want that to animate. And then later someone can come in with some actual music and say, oh, the BPM is actually slightly faster. Your entire demo just scales to match that tempo. And there's no real work involved with making it work with changing music. The only limitation I have is that the track has to be a constant BPM. I crashed it again. Oh no, I didn't. Lucky me. I think I had 3 crashes in the last week and never before. So I definitely changed something for the worse. I don't have audio with this. That's too bad. Great. I don't think so. It is compiled, so I might just have messed something up somewhere pretty recently. I'm also on my experimental branch. I'm working on some changes and indeed a visual editor for that pipeline stuff where you can just click nodes together to control which shader goes to what buffer. So probably one of my experiments has gone wrong here. Whoops. Okay. Let's do this again then. Does my scene still exist? If it does, I don't remember the name. Oh, it was just called new scene. Okay. Let's use this one then. No. It's too customizable. Yeah, so per shot I have this list of parameters with animations, and you can just add new ones as you go, and if they exist in the shader, they will automatically communicate. So the tool just brute force sends this animation data as a uniform to the shader, and OpenGL silently fails if it doesn't know that uniform.
Is the animations all floats, or are they there's some?
No, they're all floats. Just I have this naming convention based system to create factories. So you suffix it with .x, .y, and if there's two of those, then it will automatically find that it's a fact2. But in the tool, it's all just single float animations, and I have only concatenated floats and don't have matrices or quaternions or more complex data like that.
If you want to start a project from scratch, how would you make this? Where will you start with?
So I can actually do that. I have a template project in the tool that's, if you get it from GitHub, there will always be this default project. And when you create a new project, it will copy this one. There's really something wrong with this. And you can, in theory, you can just mess around with the template as it is and create your own render pipeline. But I would advise you not to, because I think the render pipeline that's there is actually pretty good. It's, it's just GGX specular and good bloom and nice depth of field that's not too expensive. So there's already a lot of features that you might want to make use of. Let's go. Huh. Okay. It is defined though. Never mind that one. So this is just a new project as it is right now. So the experimental branch has some chromatic aberration and film grain, which I'll probably integrate soon. But it's I'm just playing around with a more grainy look. And this is what you start out with. So it's actually not very far away to just create a new project. You get array marcher, you get the whole library at your disposal. The only thing that I think I could do better if I had the time was to document more of this this code, because of course you have these files that you can fill in. So if I want to change that sphere, I can go in here and just say, you know, I want a torus. And I want to switch those around. But you know, knowing that this function is there is not really clear to the user from over here. So I'm thinking if I ever get the time to just put up a web page with like well-documented stuff of what's
Would
there.
it be a help if some other people would do this?
Yeah, totally.
Collaborate on this project?
It would be really cool if people want to try it out and ask me questions about how to get started, how to use it. Like I would love anyone to just download this, install it, and see contact with me if you don't get it to run, or if you don't know where to start, or if you want to just have some hints on how to get started on ray marching. I'm super open to getting people to just try this out. Because we started out with just 3 guys wanting to make a demo, and through different expertises we got here, where we have a tool that I think is fairly easy to pick up, but it's very biased to you know, what the Poo-Brain guys know about. So it's it might be very useful if other people just take some time to pick this up and try to make something with it, and just say, hey, maybe this is easier like that, or this is really unclear to me, could you maybe document this somewhere? And then, yeah, I'm just hoping for this to grow. Actually, I think we're almost out of time, so I'm just gonna say, if there's any questions, please ask them.
4 minutes left.
You said you use Python and FTP for doing this. Does it mean it is running as well under Mac Linux?
In theory, and I believe TD Hooper recently ported it to Linux. I do not own a Linux machine, and I do not own a Mac, so I find it impossible for me to test. But I believe it actually works now, because we changed some compatibility issues and made sure it's all OpenGL 4.1. So in theory, it should not be far off, if not working already. And I would love it if you want to try that out. Just get into contact, and if you have any errors from Python coming up, I'll be glad to help decipher them and try stuff out with you.
Is Python 2 or 3?
2.7. I don't know, man, it's dying soon. What's that website? pythonclock.org or something? It's like a doomsday clock when support will stop. Yeah, that was it? Oh. There's a ton of stuff I want to add. I don't know when they will happen or if they will happen, but one thing I've realized is that these shots are containing the animation right now, and it is sometimes super useful to just put animation on the timeline. For example, the amount of bloom or chromatic aberration or fade to black is not related to which scene you're looking at. So I would love to create a visual timeline with separate events that say, look at this scene, play this animation, and just be more of a video editing interface. Because here I'm just punching numbers to move these things, these blocks on this timeline. And I can, you know, there's some features, I can duplicate it, I can move it. There's a speed and a pre-roll feature. But at the end of the day, it's I think it would be really cool to have this thing be fleshed out with interaction, so you could really move clips, cut events, and have an abstraction between what you're looking at, the scene, and the actual animation data. So you could have animations that are longer than one shot, and that's one thing I've been looking at and working on. Another thing is the pipeline editor. So I want a node graph where you can just say, I want these shaders to be the bloom pass, and I want it to feed into that pass, and I want it to get that data as an input texture. And so all this XML business is just confusing and hard to use, so I want to make a UI for that. But it's a lot of work. Oh, I also want to improve the curve editor, because currently the positive axis is down, so this is +1. Which is horrible. But yeah, never got around to fix it.
Yeah, I have a question. Is adding support for rendering geometry directly out of the question?
It's not out of the question. I've actually had point rendering working, so I could do a particle-based effect. I've had polygon rendering working with the right projection matrix. I actually changed my ray marcher to have a projection matrix that matches a polygon rasterizer instead of a spherical ray casting lens. But then it sort of quieted down because I can't figure out in my head how to make an editor for this. Like you need a component that does a scene graph and has an FVX importer or something crazy like that. And that is, it's very far off and also hard to design. Like how do you interact with this content once you can do it? Because you can, in theory, add a vertex shader to a pass and just say, I'm going to have the vertex shader output random pipes and cables and stuff and composite that in another pass and just add polygons.
Is every object defined by distance functions? If I want to have the same object in different scenes, is there a way to include it? Or do you just have to copy paste the set of text for each scene?
No, so there's in the template for the render pipeline, I define which files get included, and some of these files are shared between all scenes. So there's this file just called SDF with all the sign distance functions. And at the bottom, I think I already have some crazy stuff for like hexagon tiling or greebles that I made. And the only downside is that the more code you have in this shared library, the slower the compiler will be. Even if you don't use it, it gets this little overhead. So sometimes you need to prune stuff down. Although I found a solution in using macros. So just put a define around the code, and then in the scene just say, I want to enable this code for this scene only. So tangents are not really editable. Yeah, you can. Let's set at least a few keys here to demonstrate. Or not? Huh. Oh, I set it in the wrong scene. There we go. So in the curve editor, there's splines, and they automatically ease in and out, which is not always desirable. There's these nice buttons to make them snappy and linear. And there's this one, which is smart about continuity as well. So if I have a curve like this, it will sort of, instead of being broken, it will keep the shape. It will keep the velocity, which is great for cameras, actually. It's really, this will make a camera smoothly move and not jump in acceleration and get a lot of jerk.
Oh yeah, I would say time's over.
Yeah, I think so.
Thank you a lot for
Thank you for coming.